automatic controls and alarm system. An RO water system includes pre-filtration for particulate matter and chlorine reduction with carbon treatment. So, what is reverse osmosis? To best understand reverse osmosis, let's first look at normal osmosis. To illustrate, imagine a semi-permeable membrane with fresh water on one side and concentrated solution on the other, such as salt water. If normal osmosis takes place, the fresh water will pass through the membrane to dilute the concentrated solution. In reverse osmosis, pressure is exerted on the side with the concentrated solution to force the water molecules through the membrane to the freshwater side. This retains the salt to give us salt-free water. Particulate filtration at 5 microns is the first step in the treatment process. This filter ensures that all particulate matter is removed prior to the next step of filtration, as well as less long-term maintenance of the RO membranes. Reverse osmosis is sensitive to oxidizers such as chlorine, typically found in all city water sources. Therefore, the process and water RO water system includes granular activated carbon, commonly called GAC. The GAC is an absorbent and will reduce the levels of chlorine being sent to the RO membranes. The effluent of the carbon column passes through a higher micron capture filter to capture any carbon fines that may have been released from the vessel. The influent water has been pre-treated and is now prepared to be processed through the reverse osmosis membrane. As the water passes through the RO membrane, there is a low pressure switch to protect the pump against low inlet flow or pressure. There are panel-mounted pressure gauges to monitor the pre-treatment and reverse osmosis inlet and outlet pressures. The neighboring control panel is used to monitor water quality and facilitate operational functions. There are 3 streams that exit the reverse osmosis process. The permeate water, which is the clean, filtered, or product water, passes through the permeate flow meter and is sent to the product water storage tank. At higher salt levels, the concentrate is sent to sanitary sewer, or in some cases non-critical locations for reuse, also known as gray water recycle. In higher water recovery applications, a small percentage of the concentrate water is sent back to the inlet of the RO membrane for recycle. The salt removal reverse osmosis step is complete and the filtered water is stored for distribution and use. The product water is fed from the bottom of the tank to the distribution pump, where it will be post-treated before being fed to the facility points of use. The clean water low in salts, typically stored for a period of time, is a target for bacterial growth. Therefore, the process and water system includes a germicidal ultraviolet disinfection unit for bacteria control. Germicidal UVC light deactivates the DNA of bacteria, viruses, and other pathogens, and thus destroys their ability to multiply, which is critical in any process and lab use environment of RO product water. The UV-treated water is passed through a final filter, usually sub-micron, to filter any organic or non-organic matter from the subsequent ultraviolet treatment. In some cases, further ionic removal will be needed to meet deionized water quality. If this is required, Process and Water implements a DI polishing bed containing strong acid cation and strong basic anion resins to remove all remaining ionic constituents in the water. The product water has been post-treated and is ready to be sent to the points of use.